So, what if I told you there's a potential solution to our fossil fuel addiction, and it's literally growing in our fields right now? Sounds perfect, right? But what if that same green solution came with a hidden and very, very high price? Welcome to our deep dive on biofuels. It's a story that starts out simple, but ends up being way more complex than you'd ever imagine. All right, here's how we're going to break this down. First up, we'll look at the big promise of biofuels. Then we'll poke a few holes in that and ask if they're really carbon neutral. We're also going to get into the super tricky food versus fuel debate, check out a huge real-world test case in Brazil, and then finally try to weigh the ultimate trade-offs. Okay, so let's start at the beginning, the big idea that got everyone so excited in the first place. This was the promise of a perfect, clean, renewable cycle. So what exactly is a biofuel? Well, at its core, it's pretty much what it sounds like, fuel made from biological stuff. We're talking renewable things like crops, think corn, sugarcane, soybeans, or even just agricultural waste. The two heavy hitters you always hear about are bioethanol and biodiesel, and they're designed to work in the cars and trucks we already have. The appeal, initially, is this beautifully simple idea called a closed carbon cycle. Okay, so here's how it's supposed to work in theory. Step one, a plant, let's say sugarcane, grows. And as it grows, it just sucks up CO2 from the air. Step two, we harvest that sugarcane and turn it into fuel. Then, step three, we burn that fuel in our cars, which releases that exact same CO2 back into the atmosphere. See? No new carbon is added. It's a perfect, neat little loop. A perfect loop? Or is it? Well, this is where our nice, simple story starts to get complicated. Because when you actually look a little closer, you start to find all these hidden costs. And that leads us to the big question we have to ask. Is that cycle really and truly closed? You know, when you account for the entire process, from the seed in the ground to the fuel in your tank, what is the real carbon cost of this supposedly green energy? So this is the crucial part. The reality is just so much messier than the promise. That perfect little loop on the left, it doesn't factor in the diesel needed for the tractors, or the natural gas used to make fertilizers, or the emissions from trucking the crops to the factory. And here's the absolute biggest one. What if you have to chop down a forest to plant all those biofuel crops? Well, that releases a massive amount of stored carbon, and the whole carbon neutral idea just goes right out the window. And this is the real shocker. Because when you add up all those hidden emissions, especially the ones from clearing land, the whole equation can flip on its head. The data shows that some biofuels can actually end up being just as bad for the climate as gasoline. And get this, in some cases, they can even be worse. But you know, the carbon question, that's only half the story. There's another complication, and this one is maybe even more uncomfortable. It's the food versus fuel debate. This is a classic, difficult problem. At its heart, the food versus fuel debate is about the direct conflict we create when we start using our valuable farmland and our food crops to power our cars instead of, feeding people. And here's how that conflict plays out. The more land we use to grow crops for energy, the less land we have for food. That's simple enough. But then basic economics kicks in. As demand for those biofuel crops shoots up, so does their price, which can then drive up the price of food for everyone all over the world. And guess who gets hit the hardest? It's often the low-income countries where food security is already hanging by a thread. So we've talked about the theory, the carbon math, and the food debate. Now let's see how this all plays out in the real world with a massive, and I mean massive, test case. Brazil's Great Biofuel Experiment. For decades, Brazil has been a global leader in this whole space. They went all in on producing bioethanol, and their secret weapon is sugarcane, which just happens to be one of the most efficient plants in the world for making fuel. And honestly, in a lot of ways, it's been a huge success. The program cut the country's dependence on foreign oil, which was a huge deal for them. It created this massive industry that provided jobs, especially in rural areas. And because sugarcane is so efficient, their system does have lower carbon emissions than if they just used gasoline. Today, a huge chunk of the cars in Brazil are flex fuel. They can run on regular gas or pure ethanol. Pretty amazing. But, and there's always a but, right? That success came at a cost. The enormous demand for sugarcane fields put immense pressure on other ecosystems. Now, most of it isn't grown right in the Amazon, but there's a real concern that the expansion of agriculture in general just pushes cattle ranching and other activities deeper and deeper into the rainforest. On top of that, you've got the environmental hit of planting just one single crop over vast areas, which is terrible for biodiversity and can wear out the soil. So when you put it all together, what are you left with? Well, you're left with a series of really tough trade-offs. And as you've probably figured out by now, there are absolutely no easy answers here. And that's really the main takeaway from this whole thing. Biofuels aren't a simple hero, and they're not a simple villain either. They're a complex tool that has incredible potential, but also some really significant, undeniable drawbacks. This table really lays out the dilemma perfectly. For every single benefit, there's a direct and serious challenge on the other side. You get more energy security for your country, but you threaten food security globally. You have the potential for lower emissions, but that gets wiped out by the emissions from clearing land. And yeah, it's a renewable resource, but it's competing for the same finite land and water that we need for everything else. This is the trade-off, right, at the heart of the whole debate. Which leaves us with the ultimate question, one that policymakers, scientists, and all of us, really, are grappling with right now. As we search for ways to power our world, how do we balance our need for energy with our most basic human need for food? Can we actually fuel our future without someone, somewhere, going hungry? That right there is the real biofuel dilemma.